Hello and welcome everybody, this is Roland from graphicinmotion.com and it is tutorial time again. Let's check out what we're going to create together today. In this tutorial I will show you a very versatile technique how to inflate nearly every object inside Houdini using Vellum. In our example we will inflate the cushion of a chair, but I also use this technique to turn a wooden branch into a rubber balloon. As a first step, we'll import our model and optimize the mesh for our Vellum simulation. Then we will create an animated falloff using a tool from the motion operators collection. It's called the MOPs spread falloff. We will incorporate the falloff attribute into our Vellum simulation with a very simple vex code. Then we will add some creases to our simulation by painting in additional attributes to control the rest scale of our coloss simulation. Finally, we will add our collider and refine the simulation. Before I get started with the tutorial, I have one big favor to ask you. Please subscribe to my YouTube channel. I do this since 13 years now, and I still didn't reach my goal of getting 100,000 subscribers. So please, if you did not yet subscribe to my channel, then hit the subscribe button now, and also consider supporting me on Patreon, because this gives me the freedom to really spend more time creating educational content for you guys. So thanks a lot for all your support, and now let's jump right into Houdini and let's get started. As a first step, we have to download our chair model, and I found a pretty good one here on Sketchfab. It is also free, so you can just download it. I will put a link in the video description, of course. And in my case, I just want to download the USDC version. So I will download that and save it on my hard drive. And then we can just import it into our project. So let's create a geometry node here. And this will be our chair model prep, because I will do some preparation in here. And let's enter this and let's use a USD import node. Okay, and now let's just go to $hip, and then I can, in my assets, just load my USD model. And if I press space H now, you see it is already there, but by default you cannot access anything here because it is packed. So USDs will be imported as packed primitives by default, but you can unpack it and then you can choose polygons, and then you have the geometry here as it is. Now we have to do some preparations here, of course. You see, it is way too big, this chair. So let's add in a match size and scale it down. And let's scale to fit, and let's press space. Now I scaled it to approximately 1 meter in size, so that's okay. And I also want to make sure that the Y is set to minimum, because then it sits on our floor. Now I want to separate out these parts. So I want to create a separate group for my backrest, for my seat here, and for the frame. So let's do that. Let's just go to the selection tool on the primitives, and then you can just double click. And this should work, but you see it actually does not, because there are two parts. So this is not connected. So let's just shift click and double click on the back side here. And now inside our viewport, we'll just group this. And this is our backrest. Now I want to create another group here for my seat. And we have the same problem here, that this is actually separated. But we will deal with that in a moment. So that is our seat. And yeah, now I can just split these up here. So let's do that. Let's use a blast node here and blast away our backrest, and then say delete non-selected, and then we only are left with our backrest. And now I can keep working on this. To get rid of this separation, I will use a fuse node. So let's just fuse together the points that are close to each other. And now if I select that and double click, you see I'm selecting all of them. Now this is connected. This is very important for inflation simulations. You want to have a closed mesh without any holes. Now I just want to improve the topology of this, and therefore I will simply remesh it. So let's add in a remesh. And let's set the target size to 0.05 for now. Now let's do the same thing for our seed. So let's just duplicate all of these nodes here and change this here to seed. And now you see we have our seed here that is already remeshed. Perfect. Now I want to quickly improve the quality of my frame here, because as you see, this is intersecting with our cushions and that is not really good. So that there are two options that you have. You could either change the cushion here or you could change the frame. And in my case, I want to change the frame. So let's blast it away for a moment. And I will just blast away my backrest and my seat, and then I'm just left with my frame. And there is still this little piece here that I actually do not want to include into my simulation. We would have to set up a separate Vellum simulation with some glue constraints here, but I don't want to do that. And then there are these things here. I'm not really sure what these are. If you take a look at that here, there's something floating. I think these are just two polygons that are, yeah, some leftovers of the modeling process. Definitely, we don't want these in here. So let's just select this one here. And then select, hold down Shift, select this one over here. And I think that there's, yeah, another one over here. If you can see it in the screen recording, it's very, very small. I will also select these. And then I will just press delete to blast these away. So now I'm left only with my frame. That's good. Now let's just turn on my cushions here so that I can see these overlaps. Now, to correct these intersections, first of all, I have to connect my frame, because here we also have some pieces. If I double click here, you see they're all separate pieces, and I don't want that. I want this to be one piece. So let's fuse together everything here. And if I do that and now double click, everything should be connected more or less. You know, this frame is now connected, and this is connected, and this is connected. So that's fine. These pieces are fine. And now I want to get rid of these intersections. And the easiest way to do that is to clip this, because then I only have to do it on one side and not on both sides. So let's clip it along the X direction. And now I can just change these sides here and then just mirror it back over. And I do not have to change both sides, so just save a little bit of time here. Now let's grab one of these points up here on this rod here. Let's grab the top point and press T, and this will create an edit node. And now if I increase my radius by scrolling with my mouse wheel, you see that I enable the soft selection. And that's actually what I want to do, because then I can just move this around to get rid of this intersection here. And why am I doing that? Because if you have intersections with your collider objects, and actually this frame here is a collider, I want my Vellum simulation later on to collide with this mesh, it creates just some artifacts and errors. So let's make sure that we do not have any intersections here. So we do the same here. I just grab a point here, maybe right over here where we have these intersections happening, press T again. And now I will just reduce this a little bit, you know, the radius, that I do not shift this part here, only the part that is actually intersecting. And I can just shift it over, you see. And now we have no more intersections with this part here. That's good. Let's take a look whether we have intersections down here. I'm not sure, but I want to make sure that we don't have any intersections. So I will just grab a few points here as well. And let's say I grab this point here, press T, and reduce the radius a little bit, and just move it down a tiny bit to make sure that we have no intersections here. That's it. That's fine. Now I'm sure we have no intersections. And now I can just mirror back this frame to the other side. And you see now we have a nice frame without any intersections. Okay, so this is it with the preparation for our model. And now let's actually create some nulls here that we can export this then to our simulation geometry node. So I will create a null and call this out backrest. Then let's create another one that is our seed. And now let's create another one, and this is our frame. Okay, perfect. Colorize this green and get out of here and save our file. By the way, you can of course download the final project file on my Patreon. I will put a link into the video description. And now it's time to create the inflation simulation. So let's add in another geometry node. Call this chair inflation and dive inside. First of all, I want to bring in my model. So I will use an object merge here and I call this my backrest. Then I duplicate this and call this my seed, and I duplicate it again and I call this my frame. Now let's link these up with the nulls that we created in our preparation here. So we have the backrest here, we have the seed here, and we have the frame. Okay. So you see we have everything in here that we need. So let's start with these two. And what I want to set up now is actually a falloff that will control the inflation. I don't want to inflate my object all at once, but I want it to run over the surface. And I want the inflation to start here on this side and on this side, and then just continuously run through our object. And the easiest way to do that is to use some MOPs tools. So if you're not familiar with the MOPs tools, I would really recommend that you check these out. So MOPs stands for motion operators, and this is actually a free plugin collection, or free tools collection, I should say, that you can use inside Houdini. And it is made to make the life of motion designers in Houdini a bit easier. So there are two versions. There's a free version and there's a paid version. The paid version includes more tools, but I use the free version. And if you don't have it, I really recommend that you pause this video now, download MOPs, install it, and then continue following this tutorial, because we will use a very useful tool of this toolbox that is called the MOPs. What is it called? The MOPs spread falloff. Yeah, this one here. With the MOPs spread falloff, you can create a falloff very similar to an infection simulation or an infection solver. And to make this work, we need a start point group, as you can see here. So we have to define some starting points. So we could come in here now and just select a few points. Let's see, maybe over here, just select a few. It doesn't really matter. And then go over here, hold down Shift and select a few points over here as well. Then group them. And let's actually bring this before our MOPs falloff and call this my start one group. Now I can go to the MOPs falloff and specify my group here. Now, by default, let's preview this falloff. Nothing is happening. If I scrub through my timeline now, you see nothing is happening. And there's another problem that I just see, that it is trying to remesh this every frame. And that's something that I forgot when we were preparing our model. In the USD import, it imports it every frame. You see here the frame import is changing. So if I go to frame number 25 or 21, then it again imports this USD model, and then it has to run through all of these operations again. We definitely don't want that. So let's just delete the channels here and let's just set this to frame 1, because then it just imports it at frame 1 and we do not have to care about this throughout our timeline. So this is something that is important because, of course, USD can contain animation as well. So we can set it up like that, and then we don't have this problem. Now let's go back to our inflation simulation and let's deal with our falloff. To make this work, you have to go to the Animate tab, and here you can now animate this spread value, as you can see here. And to make this spread a little bit more interesting, we can add some noise. So let's apply some noise. And I just want to increase the frequency here a bit, maybe to 4 Let's add in some more octaves here to make this a bit more detailed. This looks pretty good. And now I can animate this and I have a nice organic fall off. And that will actually control where our object starts to inflate. So I will create an animation and I will start on frame 1 with a value of 0, and over the duration of 50 frames, I will just set this to 1 point. Let's see how much I need here. I need a little bit more, 1.2, until everything is white. That's important. Alt click to add a keyframe, and then I shift click, and I want this to be a linear motion. Now we have this fall off animation. Of course, you could build something like that with MOPs or with wax wrangles if you know how to do it, but these MOPs tools are really cool because you have everything inside. And what does this MOP spread fall off actually do? It just creates an attribute that you can rename up here, and this creates a value between 0 and 1. So right now it is called our MOPs fall off, and if we take a look at the spreadsheet, you will see that it is here on our points and it has a value between 0 and 1, and of course all these in-between values that represent these fall-offs. So let's rename this because I think MOPs fall off is a little bit of a long name. So I think we'll just rename this to, let's actually say I want to rename it to activate. That's also good. Okay, so now I have my attribute that is called activate and it's saved on our points. Now I want to build my Vellum simulation. So let's add in a Vellum configure balloon setup. Let's add this in here. And let's also add in, let's revert back here to frame number 1, and let's also add in a Vellum solver. On our solver, first of all, let's go to the forces and turn off our gravity. And now we can just set up a very simple inflation simulation. By the way, if you want to learn more about Vellum, then I would really recommend that you check out my website. There are a lot of tutorials, and there's also one that is actually pretty similar than what we are doing here, but with a bit of a different technique, the Fluffy Pillows one. But if you want to learn more about Vellum, I have 3 beginner guides about Vellum simulations. And I also have this premium course here that is called the Vellum Playground. And that is available through Patreon. So if you support me on Patreon, if you choose the full access tier, then you can get access to this course. And here I cover really everything. So I cover art directing splashes like this chocolate project. I cover mixing fluids. I cover grain simulations and snow dissolve things, cloth tearing advanced setups. Then we check out some constraint setups with glues. I also have a foil balloon thing here. So this also deals with inflations, also very interesting project, which we built from start to finish. And then I have some basic introduction tutorials here to really cover everything related to Vellum. So if you want to check that out, I will put a link into the video description. And of course, if you support me on Patreon, you would support the channel. So check this out, please. It's really worth it, I hope. And now we will continue with our inflation simulation here. And the easiest way to inflate an object with this setup is to just increase the rest length scale. So if I put this to 3 and then just start my simulation, you will see what this does. And now it just starts to inflate this object. It will not look that great because, yeah, we have to add in some details, change some settings here to make this work a little bit better. And there's one thing that I don't like. I think that the resolution is a little bit too high. My simulation is very slow. So let me quickly go back to my model prep. And just for the sake of this tutorial, I will reduce the resolution here a little bit and set it to 0.75. Let's do this on both of these remesh nodes. In my original project that you saw in the beginning and the preview video, I actually used 0.005. But I will just reduce this a bit so that this runs a bit faster. Now, of course, the problem is that our group will not work anymore. So we'll just have to reselect these points. That's no problem. But we could, of course, also do this with a procedural method. That is probably better because in case if you want to increase the resolution later on, then it will not break. So let's do that. Let's bring in a sphere, because then we can do it the procedural way. And that makes more sense here. So let's bring in this sphere. Let's do it like that. And the sphere can be way smaller. That's way too big, you know. We don't need this. Just a small sphere that will grab a few points, and can move this up here now to cover this part here, like so. And then we just duplicate it over. So let's drag another one out here and bring it over here just to cover a few points here. That's fine. Now let's merge these two together, and let's bring this into our group node. And now instead of using this one here, we can use keep in bounding regions, and we just select the bounding volume here. And this should now work. Let's see. It did not work. Oh, maybe I have to use the bounding object. Yeah, that one was the right one. Okay, so now we selected our start groups, and these are actually procedural. Now I can change the resolution and it will still work. So let's check out our inflation simulation for a moment. And of course, the MOPs falloff now has no influence because we did not actually set it up. And you also see that it doesn't look really good. So let's turn off this template here, and let's improve a few settings here in our Vellum simulation. So first of all, I want to increase the stretch stiffness a little bit. Then I want to decrease the bend stiffness so that we get a lot more wrinkles. And I also want to increase the stretch stiffness of my pressure constraints, because then the inflation will be a little bit more abrupt, you know, as if you would inflate a balloon. Normally this is also very abrupt and quite obvious. And there's another thing that I want to change, and that is the rest length scale of my cloth constraint. And this will just enable our cloth to expand a little bit to grow the surface. And if we put it to 1.1, then you can imagine that each of these constraints that is created here is able to expand its size for 10%. And this way we will get a little bit more surface, and then we will get a little bit more wrinkles, and it will just look nicer. Let me turn off this preview for a moment, because then we can see this a bit better. Now let's run this simulation again. With these changes, you see it gets fluffier, it gets more bendy, and we get nicer wrinkles. And that's exactly what I want. And because the surface of our mesh now got bigger, we can increase the rest length scale of our pressure constraints. So these things always have to play together. So depending on how big your mesh is, depending on how big the surface is, you may have to adjust these rest length scales if you want to apply this technique to another mesh. You see now it looks a little bit better, and we get a bit of a stronger inflation. We will see whether this is too strong or not, but I think that it is quite nice. Now, the next step that I want to do is actually to bring our spread falloff here into this simulation. And to do that, we will use a technique that is pretty simple. There is an attribute that is called the stop attribute. And let's create this for a moment. Let's just use an attribute create here, and let's create this attribute. It is called stopped, so you have to name it exactly like that. It is actually a point, an integer attribute. And if you set the value to 1 and run your simulation, you will see what's happening. You will see that nothing is happening, because now all of these points have a stop value of 1. And stop value of 1 means that the stopped is active, and that means that Vellum will not have an influence on this point. If we set this now to a value of 0, then of course everything will move again with our simulation. And you probably already know where I want to go with that. I just want to use my activate attribute to create a stopped attribute. I could name this stopped right from the beginning, but the problem is that Vellum is not able to take changes over time into account. It just takes a look here on this first stream, what attributes are available on frame number 1, and then it starts its simulation, but it does not continuously read in the data here. So we have to set this up manually. And to make this a little bit more obvious, I want to use a two-step operation here. So let's do it like this. We now have a stopped attribute. We actually don't need that. We can just get rid of this. And now I want to create a stopped attribute using a wrangle, and I want to take into account this activate attribute that we created. So let's use an attribute wrangle and call this set stopped. Now with this wrangle, the only thing that I want to do is to define a stopped attribute that will actually take a look at our activate, and then we'll divide this mesh into two areas, one where our points are active and the other one where our points are inactive. And we can do this with a simple if statement. So we say if add active or activate, how did you call it? Activate, yeah, is bigger than 0.5, then do the following thing. So let's add in curly brackets here. I want to set the I at stopped attribute. So now I'm creating this attribute using a wrangle. Let's think about this for a moment here. Let me quickly take a look. So we want to set it to be active wherever the value is higher than 0.5. So I will just set it to 0. Stopped should be 0 here. And in any other case, so else, I at stopped should be 1. And that's it. That's all I want to do here. And if we take a look now at that and turn off our MOPs fall off preview, and we just take a look at our stopped attribute here, which we can do here. So let's visualize that. Now you see that we actually separated these. So these pink points here are inactive. That means they are not taken into account by the Vellum simulation, and these purple points here are active. But still, our solver doesn't know that. So we have to bring this into our solver. So let's enter our solver. And here, I again want to use a pop wrangle. And there are many ways how you can do something like this. In my case, I will just use a point function to read out the data that we created outside of our wrangle or of our solver, because I think that this is a very versatile and also simple technique. So the only thing I want to do here now is say I at stopped. So basically I create this attribute now again inside my solver, and I want to read out data from my geometry stream. Now to do that, I have to give this wrangle here, this one here, access to the data that comes into our solver. And we have to do this here into these inputs. We can say that input number 1 just should take a look at the first context geometry. And let me quickly close this up. The first context geometry just means this first stream here, this input. That's it. And now our wrangle can actually take a look at our data that we created on the points. Now, I at stopped equals, and again, I want to use the point function here. And the point function requires two values. First of all, the geometry stream, which is 0. Then it requires a string, the name of the attribute that you want to read in, which is called stopped. That is what we created with the wrangle, with the if statement. And then you have to tell it at which point it should look. And I want it to look at all points, so at pt num. Now it takes a look at every point. And now this is it. So we can now call this set stopped. And let's take a look. And now this should work. So this should take our fall off into account. And you see in the beginning, nothing is happening. And then it starts to inflate only at these points where our fall off is actually activated. Pretty cool. And that is basically already the technique. So this is the secret. You can apply this to nearly any object and to nearly any Vellum simulation, not only for inflation. You can use this for cloth tearing. You can use it for everything. The stopped attribute and Vellum is pretty cool because, yeah, you can just activate Vellum simulations using an attribute. But if you want to learn how to make this a little bit more interesting, then stick with me. I will show you one or two other tricks here. So in my fluffy pillow tutorial that I released a few years ago, I showed you how to create creases. And back in the days, I actually made everything here on the constraint stream. But when I started playing with this stopped attribute that is just living on the points on the geometry stream, I also thought how to create wrinkles just using the same technique here. And it's actually pretty simple. And so I wanted to share this. So to add in some wrinkles, we could now paint another attribute, and therefore we can use an attribute paint. Not this one, but attribute paint. And we will just call this, let's say, instead of mask, we will call it edge. So this will just create an attribute that is called edge. And now we can paint this in. And we will not see it now, I think. No, we do not see anything here. So let's take a look whether we can visualize that. Sometimes I need to reset my viewport here to make this work. So let's see. Yeah, now it works. Okay. So let me quickly get rid of this, what I painted here by holding down Control. Now I can erase it. So I just want to paint in a very rough attribute here. And again, blue is 0 and red is 1. So this is what we are doing here, just painting some values in here. And that's what I really love about Houdini, that if you understand these basic concepts of painting in some values or saving some values on points, you can do so many cool things. So this was not that good. Let's do this again. I cannot really see the fold here. Yeah, like that. Let's say this is fine. And of course, I could come in here now and create more. You could paint it here, along here, if you want, So let's maybe also do that. And I will just speed this up a little bit. Okay, so I created some attributes here, my edge attribute, and painted it very roughly around my backrest. And now we can use that to actually specify a value in our simulation. And we can use it to specify our rest length scale here, because the rest length scale, as I said, determines how far your surface of the cloth is able to expand. But of course, if you set this to a lower value, so if you set this not to 1.1 but 0.5, this will shrink, and we can take a look at that. And now this has nothing to do with the attribute. I just lowered the value overall, so our whole mesh will now try to shrink down. And you see, this will create something also very interesting, because now with our ongoing fall-off, our cushion will suddenly shrink and inflate. So this could also be a nice effect if you want to achieve something like that, maybe. But that's not what we want to do. We just want to use this value to determine certain areas where it will try to shrink down and other areas where it will expand. So that's what I'm doing with this edge, attribute. Actually, to be honest, the name edge is not really good. I should just call it wrinkles, or better would be actually rest scale. That's the best name here, because then we know what this really does. So let's say that this is the rest scale. Now, the rest scale right now, this attribute is creating values from 0 to 1. And I definitely want to remap these values, because 0 is not a really good value for the rest scale, because this will try to shrink into infinity, into 1 point, into singularity, and singularity always causes chaos. So let's remap that attribute. And we want to remap the rest scale. And now we have to think about this. So wherever my attribute here is, now I do not see this anymore. That's interesting. I hope that I did not erase it because I changed the name. That is actually possible. Let me quickly reset my viewport. And let's take a look at the rest scale. Yeah, actually I did. I erased it, sorry, because I changed the name here. That was not the best idea. So I have to put this in again. Sorry for that. I'll be back when I did it. Okay, so now I painted in this attribute again. So now it is called rest scale, and still we have values between 0, which is blue, and 1, which is red. So I wanted to remap that now, and I want the red areas to be, of course, smaller, so these should shrink. So wherever it is 1, I want to set this to a smaller value, like 0.3, and wherever it is blue, so wherever it is 0, I want it to set to 1.1 as we had it before. And this is now the rest scale. Now, the funny thing is that, of course, as it is right now, this will not be taken into account by the Vellum solver. Now, to make this work, we'll use exactly the same technique as here. So we could now actually just use a wrangle, but there is another option here. Vellum configure constraint properties. Now it's called Vellum constraint properties node. And with this, you can manipulate all of these values that you see here inside these constraint wrangles. Now, the important thing here is that we want to target a special rest length scale, and we want to target this one here in our cloth constraints, because our pressure actually has also a rest length scale, but you can differentiate between these using these output groups. So I want to specify an output group on my cloth here, and I will rename it to cloth so that I know that this is especially only this one here. And then I will create a second output group for my pressure, and I will call it pressure, because this way I will not mix these rest length scales up. Now I can go to the Vellum solver, go to the constraint properties here, and we can specify these groups here. And let's choose our cloth group and then change the rest length scale. Now I can use the expression here. And to change that, I just take a look what name this parameter has. And it is actually also called rest scale as our attribute. And now again, I can use a point function. And if I set up the inputs correctly here, let us use input number 3 and set it to first context geometry. Now again, so that it can access the data that is in our first stream. This time I don't have to put 0 in, because I actually have an input number 3, and this is input number 2 in a wrangle. This is sometimes a little bit complicated, but that is Houdini actually. And we do the same here, we just tell it to take a look at this stream here, input number 3. We want to read in the rest scale and on all the points, and we want to map this to our rest scale here. So this should be it. Now if we run our simulation, our painted attribute should have an influence. So you will see that on the edge here, it tries to shrink down. You can already see that here. And it will create some wrinkles. And yeah, let's see whether this looks nice or not. I think that it actually doesn't look too bad. It just shapes our cushion a little bit further, Yeah, it actually looks quite nice. And we will get these nice folds down here. So I'm actually happy with that. Maybe I should smooth it out a little bit, because the attribute is a little bit rough, as you can see here, because I didn't really pay a lot of attention when I painted this. So let me smooth that out a little bit. And we do that before the remapping, So let's bring in an attribute blur here to make this a little bit nicer. And let's say we want to just smooth out our rest scale. Let's take a look how this looks like now. So I blurred it out. If we turn this off, yeah, this makes it definitely a bit nicer, I guess. Yeah, okay, let's do it like that. And another option would be to go to our pressure and lower this a little bit. I think 5 is a little bit too much. Maybe 4 is enough. And now let's check out this solver or this simulation again. Let's turn this off and let's check our result. I think that this is quite funny. So it looks really nice. It looks like kind of an animal. If we put 2 eyes on this and a mouth, then we have a very funny animal here. Okay, so there's only one more thing to do. And of course, we would have to set this same thing up here for our seat. You know, you could just copy everything over here and then just repaint these things here if you want to use it. That's actually all you have to do. And of course, create a new falloff, you know, a new falloff animation with the MOPs falloff. And then this will also work for the seat. But I also want to bring in my collision object, and my collision object is my frame. So let's bring this in here by just plugging it in here. And in my example that you saw, I let the cushion, the inflated version here, float away. And I did this by simply animating the gravity here on my solver. So I will show you this. This is the last thing that I will do in this tutorial now, just to show how I did that. I will just set up a keyframe with a value of 0 on the gravity here on the y-axis. And let's say over the course of 2 seconds, we will increase this to a slight value, not too much, you know, and we can turn off our solver for a moment so that it does not calculate. And we will set it to something like 0.3, a positive value because we want it to go up. And then after, let's say 100 frames, we can set this back. Oh, I forgot to put in a keyframe here. 0.3, alt click, yep, like that. And then we can just go back to 0 again here so that it does not float into eternity. And if we take a look at that now, let's see, maybe we can even do something like that. We will see whether this is necessary. Okay, so now we have, first of all, the collision in here, and then it should also start rising up during the solve. So let's activate this again, and I will calculate this one more time, and this is the final step of this tutorial. Okay, so the project is finished, and I also took a few moments to prepare the second part here, our seat. And I ran into one problem that I want to address here. I just duplicated this over, as I said before, and set up a new paint attribute here for my rest scale attribute, like so. But when I started to bring these things here together, because then I just merged together these two geometry streams and these constraint streams and brought this into our solver, then it gave me an error because there actually was a problem with an ID attribute. And I think that this ID attribute was created or is created here in this step when we create this MOPs spread falloff, because up here we have no ID attribute and then we suddenly have an ID attribute. So to solve this problem, I just deleted this ID attribute before I bring everything into Vellum. And this solved it. So just in case if you're running into this problem, when you want to merge two streams that contain some MOPs falloffs or MOPs tools, then you may have to get rid of this ID attribute. I think that the ID attribute is used if you want to further on use other tools from MOPs, but for our setup, it's really not necessary. So in case if you get an error, then just delete the ID attribute from the points. And yeah, that's it. So now we can take a look at this final result together. And I think it turned out quite nice. There was one little correction that I had to do. I just tweaked the frame here a bit because there was also an intersection on the back here, but I already showed you how to do that. So as I said, you can get this whole project file for free on Patreon, but you have to be a free member of my community. Okay, so this is it with this tutorial. I hope that you learned something and that it was somehow useful for you guys. If you like my content, I invite you to join me on YouTube, subscribe to my channel, and also please consider supporting me on Patreon. Your support is very important. Without your support, I would not be able to create tutorials, to spend the time. So the more of you support me, the more freedom I get to create educational content for the community. So thank you very much for all your support, and I really hope to see you soon. Goodbye.